Here we're going to investigate what happens with the area. If we look at the little square here on the left-hand side, we have a square that's 2 centimeters by 2 centimeters. We know that area is length times breadth which is 2 centimeters by 2 centimeters, giving us 4 centimeters squared. Now we've increased this square. We're in a scale of 2 to 1. So we've made it 2 times larger. How do we know that it's larger and not smaller? Well, we think of this 2 to 1 as being 2 divided by 1. We see which number we've got on the top. 2 is larger than 1, so it's 2 times larger. If we had done it 1 to 2, we would have had 1 on the top and 2 on the bottom, so it would have been half. But we've enlarged our scale by 2 to 1, so that now we know that this bottom is a length of 4, and the top is a breadth of 4 centimeters as well. So what happens then to the area? We have doubled the length, so the length has only doubled, but what happens to the area? Well, instead of calling this length here 2, we actually know that it's 2 centimeters originally, and then we've doubled it. And this can also be thought of as 2 centimeters doubled. So the area of our new square is the 2 centimeters that we had originally, but doubled, multiplied by the 2 centimeters that we had originally, that's also been doubled. So here we have the 2 centimeters from the original length, here and here, and then we have doubled the length and the breadth. A lot of people seem to think that once we increase the length by 2, the area should increase by 2, and they get a little bit confused when they see that the area increases by 4. Why is that? Well, if we look at these two red terms first, 2 times 2 is 4. And then the length that we doubled is left over here from the green, and the other length that we doubled is left over here from the green. What is 2 times 2? Well, 2 times 2 is the same as 2 squared. So we've doubled the length twice. You can say that we've doubled the length and we've doubled the breadth. So we get 2 times 2, which is 2 squared. So it's actually increased by a factor of 4. So the area always increases by a factor of 4. 4 times 2 squared is the same as 4 times 4, which is the same as 16 centimeters squared. So we can see that the original 4 centimeters squared gave us an area of 16 centimeters squared when we doubled the length. Well, what's going to happen then if we look at the volume? If we look at the volume of this cube, we know that the volume is the length times the breadth times the height, which in this case is 2 times 2 times 2, which is the same. 2 times 2 is 4, 4 times 2 is 8. So we get a volume of 8 centimeters cubed. Why do we have centimeters cubed? Well, we've multiplied 2 centimeters by 2 centimeters by 2 centimeters, and anything multiplied by itself 3 times is cubed. So these are our units. We've got 3 lots of centimeters, centimeter times centimeter times centimeter, giving us a unit of centimeter cubed. Cube just means that number or that letter multiplied by itself 3 times. So what's going to happen then when we have a volume now, where we've increased everything to a length? We've doubled all the lengths, so we've got 4. Same thing here. We can think of it as being the volume, and we change colour here. The volume will be length times breadth times height, which will be 4 times 4 times 4. That can be thought of as the original 2 centimeters that we had, 2 by 2 by 2, multiplied by 2 cubed. Why multiplied by 2 cubed? Well, we've doubled each of the lengths, and therefore we can think of this first 4 as being 2 times 2, multiplied by the second breadth as being 2 times 2, multiplied by the third breadth as being 2 times 2. So we can see here that we've got our original 3 lengths of 2, here that I'm underlining in red. That's the same as 2 times 2 times 2, multiplied by the increase in length, the doubled length, which I'll write in green, 2 times 2 times 2. In this particular case, we get 2 cubed here, which we know is 8, multiplied by another 2 cubed, which we also know is 8. So 8 eighths are 64 centimetres cubed. So how have we changed in volume? When we have just doubled the length, we would expect the volume to be multiplied by the original volume, which is here, multiplied by the length, the dimension that we've increased, the length, the breadth, and the height, which is 2 cubed in each case. So the increase in volume is multiplied not by 8, but you should always think of it of the increase in the dimension, which in this case was we doubled it, so we multiplied everything by 2, but we multiplied it by 2 cubed because we multiplied the length by 2, the breadth by 2, and the height by 2. So we multiplied by 2, by 2, by 2. And this sort of explains the reasoning why if you double the length, you automatically increase the area by 2 squared. If you double the length, you automatically increase the volume by 2 cubed.